So it's going to be the term of Iași, of students of Iași. This time they're going to present something live about SophistiCat analysis. Thank you. Iași, it's your turn.
Can you see my share screen?
Yes, it's okay.
Hello, everybody. We are representing Colegiul Național Constantin Negruzzi from Iași, Romania. My name is Flavia Chiribou, and I'm a 10th grade student. Next to me are my teammates, Magda Moșneagu, Matei Marcel, and Eliza Sârcu. We are very thankful and grateful for both of our teachers, Ioana Anton and our researcher Iulian Soleriu from University Alexandru Ioan Cuza of Iași, Romania, for providing us and helping us with the problem, the SophistiCat analysis. Our research deals with calculating the speed of a cat on a road which is full of cars so that she won't get hit by them. Given the measure of the cars on the road, we must find the minimum speed of the cat and also the time she needs to cross the road safely. Misty is a SophistiCat that was away on some business, and now she is in a big rush to get home. In order to get back to the loved ones, she has to cross a road of breadth B. Unfortunately, the road is full of cars, and she sees no big gaps between them. However, after a quick but thorough analysis, she has noticed that all cars run in one stream, and each car has roughly the same width A. Moreover, all cars are following each other in a single line at the same speed, let's say V, keeping the same distance, let's say D, among them.
She is planning to run in a straight line at a constant speed, say S, from one side of the road to the other. With this thought in mind, she has calculated the right angle, say theta, that this straight line will make with the direction of traffic. However, being extra cautious and willing to keep her precious fur untouched, she would be very thankful if you could help her. She wishes to double-check with you her minimum constant speed S that she has to run. Also calculate the crossing time corresponding to S and theta.
We thought of AD as the cat's trajectory. Thus, we considered the first case in which the cars are static because they don't move at all. They might be waiting for a traffic light to turn green. The fastest way for Misty to go from point A to point D is in a straight line. So the angle theta will be equal to 90 degrees. Therefore, the distance she will have to run is equal to the width of the road, so B, at the time she will have, is equal to the time when the traffic light is red. Its speed will be calculated by the formula speed, which equals a distance over variation of time. So S equals B divided by T. We have to find the minimal speed of our cat, so the time in which she can cross the road must be maximal. If the speed increases, the time available for Misty to reach the other side of the road decreases.
The second case is represented by an usual image of the road, so when the cars are moving. The three rectangles represent the cars that have constant speed. Our Misty must pass to the other side of the road between them. Let's assume AD is the trajectory, the straight line, of Misty. The easiest way for the cat would be to cross the road as in the following image. Otherwise, if it crossed perpendicularly, it would be hit by the car. We assume Misty starts from point A and ends in point D.
We try to include in this graph the position that cat will have while crossing the street. Therefore, Misty is represented by the blue dot, and its route is starting from point A and ending at point B. In the second image, the cat avoids at the limit, hitting the back corner of the right side of the yellow car in front of it. And in the third picture, it also avoids any contact with the back corner of the yellow car, which is overtaking the cat. In the fourth image, the cat avoids hitting the front corner of the blue car, being in front of it. And in the last image, the cat reaches point D, thus crossing the street successfully.
The notation given in the problem: A, the width of the car; B, the breadth of the road; D, the distance between the two cars; V, the speed of the cars; S, cat speed; theta, the angle that the cat's trajectory will make with the direction of traffic. The notation we made: A, the point where the cat lives; B, the place where the cat should be so as to avoid at the limit a collision with the yellow car; C, the place where the cat should be so as to avoid at the limit a collision with the blue car; and D, the place where the cat will arrive.
Firstly, we consider a Cartesian coordinate system with the origin B, as in this image right here. The speed of the cat, s, has the direction bc. Its horizontal component is equal to s multiplied by cosinus of theta. Therefore, the horizontal component of the relative speed of the cat related to the blue car is s multiplied by cosinus of theta minus v, which is all greater than 0. Misty passes the danger zone bc in time t if d plus s multiplied by cosinus of theta multiplied by t is greater or equal to 0. Where s multiplied by cosinus of theta minus v multiplied by t represents the relative distance of the cat to the blue car traveled in time t.
The width a r will be equal to s multiplied by sinus theta. Therefore, t will be equal to a divided by s multiplied by sinus theta. We will thus replace, obtaining the following relation: the difference of s multiplied by cosinus theta minus v multiplied by a by s multiplied by sinus theta plus d, which will be greater than 0. So is that multiplied by a multiplied by cosinus theta minus plus d multiplied by s multiplied by greater than 0, since that s will be greater or equal a multiplied by v divided by a, or multiply cosinus theta plus d multiplied by sinus theta.
We want to calculate the minimum value of s, the speed of the cat, as the angle theta ranges between 0 and p over 2. We observe that in order to obtain this, we have to find the maximum value of the following expression: e of theta equals a times cos of theta plus d times sin of theta, with theta between 0 and the factor root of a square plus d square in the above expression and get e of theta equals with root of square plus times square or times cos of theta plus d over root of a square plus d square times sin of theta, as a over root a plus square everything square plus d over root of a square plus d square everything at square is equal with 1. There is an unique angle gamma, which is between 0 and p over 2, such as the cos of gamma, which is equal with a over root of a square plus d square, and the sin of gamma, which is equal with d over root of a square plus d square.
Therefore, tan of gamma is equal to d over a, and thus gamma will be equal to arctan of d over a. Hence, e equal to root of a squared plus d squared, all times by cosinus of theta multiplied by cos of gamma plus sinus of theta multiplied by sinus of gamma, and the expression e becomes square root a squared plus d squared multiplied by gamma minus theta.
Magma occurs when cosinus of theta of gamma minus 0 equals 1, as both theta and gamma, which fall between 0 and pi over 2, this means that theta will be equal to gamma, which will be arctan of d over a. In conclusion, the minimum constant speed of the cat that guarantees a safe crossing of the road must be, let's say, s minimum, a multiplied by v over square root of a is the and the right angle needed is theta minimum, which will be arctan of d over a. The corresponding crossing time t of the entire road from point A to point D is ad over s, which will be d over v multiplied by the sum of cotangent of theta plus d over a. If the cat runs at minimum velocity, then theta will be arctan of d over a, and thus cotangent of theta will be a divided by d. Therefore, t will be equal to b over v multiplied by the sum of a over d plus d divided by a. And then if Misty runs at minimum velocity, the crossing time of the entire road will be t minimum, which will be equal to b over v multiplied by the sum of a over d plus d divided by a.
The subject could be more relevant to us if we take for the particular cases. The first one is crossing the town face of the car limited to v, which equals 50 kilometers per hour, which approximately means 40 meters per second. We assume that the width of the cars is a, which equals 2 meters. The distance between the two following cars is d, 5 meters. And from the formula, we obtain that as a root of 2 by 5 divided by the root of 2 powered by 2 plus 5 powered by 2, which will be equal to 100 divided by the root 29, which approximately means 18.58 kilometers per hour, which is approximately 5.20 meters per second.
As the average speed of a running cat is 40 kilometers per hour, as it says in the Wikipedia, which means that Misty needs 9 seconds for each 100 meters, we conclude that our minimum speed from above is realistic. In the breadth of the road, b is 7 meters, and Misty runs at minimum velocity, we obtain that the crossing time of the entire road is t minimum, approximately equals to 1.45 seconds, and the angle corresponding to the minimum velocity is theta equals to arctan of 5 over 2, which is approximately 1.19 radians, which is about 68 degrees.
We consider the speed of the cat as a function of theta. So S of theta equals A times V over A times cos of theta plus D times sin of theta, which is equal with 2 times 14 over 2 times cos of theta plus 5 over sin of theta.
You can see in the first picture, which was made with the help of MATLAB, the cat's velocity as a function of theta. Here, v equals 50 kilometers per hour, and a equals 2 meters, and b 7 meters, and d 5 meters.
We also consider the cases where the constant distance between following cars are 10 meters and 30 meters, to avoid rush hour, for example. For d equal to 10 meters, then the minimum cat velocity is 2.72 meters per second, and the crossing time of the road at minimum velocity will be t minimum, which is 2.6 seconds, and the angle corresponding to the minimum velocity will be about 78 degrees. For d, which will be 30 meters, then the minimum velocity cat will be 0.93 meters per second. The crossing time of the road at minimum velocity will be 7.5 seconds, and the angle corresponding to the minimum velocity will be about 86 degrees. This means that if the cars are further apart, Misty can cross the road almost perpendicular on the direction of traffic at smaller velocities, and the corresponding crossing time is larger, as Misty will be no longer in a big rush.
If we consider the time needed to cross the street as a function of theta, t by theta will be equal to b over v multiplied by the sum theta plus over a. Then we obtain the graph displayed in the second figure. We observe that the larger the angle theta is, the lower time Misty spends on crossing the street. And in the second figure, we can see the crossing time t as a function of theta. Here, v is equal to 50 kilometers per hour, a 2 meters, b 7 meters, and d 5 meters.
Our second case that we took is Misty crossing a motorway. The speed of the cars on a motorway is about 130 kilometers, approximately 36 meters per second. We said that with all cars, the width will be 2 meters, and the distance following cars is 5 meters, and the breadth of road will be meters. From the above formula, we obtained that the minimum velocity of the cat must be 13.38 meters per second. This is realistic only if Misty is really fast by nature, and we can assume that Misty is trained for speed. Also, we will get the crossing time of the road at this minimum velocity at 0.56 seconds, and the optimal angle, which is theta minimum, about 68 degrees.
If you now consider that the distance between the cars is higher, say d equals 10 meters, we obtain that S minimum is equal with 7.06 meters per second. That means t is equals 1, and theta minimum is equal approximately equal with 78 degrees. If we consider the speed of Misty as a function of theta, then S of theta is equal with 72 over 2 times cos of theta plus 5 times sin of theta.
In the third picture, the velocity as a function of theta, here v equals 130 kilometers per hour is meters, b 7 meters, d is 5 meters. The cat's crossing time as a function of theta is displayed in the first picture, which here the v equals 130 kilometers per hour, a is 2 meters, b 7 meters, and d is 5 meters. Crossing time as a function of theta.
In conclusion, in order for the cat to successful street, it must have a route determined by the trigonometric function of a unique theta angle. The speed and the time in which it travels the street are determined by the measurement compared to the angle made by the trajectory of the cat on the road. In order to calculate the cat's minimal speed, we have to consider the maximal value of the angle theta. Through some numerical calculation, we come to the conclusion that both the cat's speed and the time of crossing the street can be written in the form of trigonometric equation according to theta, so that our mathematical cat has a route as safe as possible. In the case when the cars are static, the cat can cross the street with any speed and any trajectory angle which falls in the radius p, so it can both run in case of haste and velocity.
Here's a picture with all of our cats, and they all thank you for the attention and patience.
So, bravo, dear students, for this presentation with many formers, many calculus. Is there maybe a question? Yes, we have 2 questions. No.
Just wondered if this could have any practical applications.
Did you hear the question? So one of our students asked if you see any application, any concrete application about this problem.
Yeah, we were actually impressed that the cat has a really fast speed. We research on Wikipedia and a lot of other sites. We think this as a application in real life, but we also
force our students just learn our math problems. And
may I ask in which grade you are at school?
Yeah, 3 are in
English grade? 10th grade?
10th grade.
And
10th
I'm
grade.
in 8th grade.
Okay. And there was another question. Yes?
Yes, perhaps something that I just missed during the presentation. I was wondering, with all the cars in the line, should there be a maximal angle and a minimal angle? Because on the for functions, I saw that it started at 0 degrees and went all up until 180, I suppose. And I was wondering, should there be a minimal angle and a maximal angle?
Have you heard the question?
Could you please repeat?
Yes, the question is, you found a maximum angle, but is there maybe a minimum angle? Because if I understand correctly your question, a minimum angle that allows the car to cross the street, to pass by without putting the cat in danger. You understand that? Okay. Imagine that with a minimum angle, it could allow the car to drive by without putting the cat in danger. But you found the maximum angle. So the question is that maybe we could see 2 points of views. That the cat crossed the street before the car, or it could cross the street after the car. Anyway, it could be another.
I actually think of this, but that would mean that the speed would be at maximum.
Faster.
Yes, because you could use the speed as another parameter.
But this could be, we can get into that. Like we would like to calculate the minimum angle.
Anyway, it was
Thank
a
you
very
for
impressive,
the suggestion and question.
very impressive presentation. Thanks a lot again.